Hello, my name is Shreya Jadhav, studying at DY Patil Institute of Technology, Pune. I will be presenting my internship project titled Microwave Oven Simulation using Embedded C, which I completed during my embedded system internship at Emertxe Information Technology. In this presentation, I will explain the concepts I learned during the internship and how those concepts were practically implemented in the form of a real world embedded application. This internship was focused on embedded systems development with an emphasis on embedded C programming and microcontroller based application design. During the internship, I learned how to interface hardware components, write modular embedded software, and design applications based on real world requirements. All the concepts taught during the training were reinforced through hands on implementation. Internship goals. The main goals of this internship were to understand embedded C fundamentals, learn how microcontroller peripherals work, and apply these concepts to a real world application. Another important goal was to follow an industry style development approach where applications are built based on requirement documents. Embedded system. Now, what is embedded system? These systems are designed to perform a specific function efficiently and reliably. It is a dedicated computing system designed for a specific function. Embedded systems are commonly used in everyday appliances to perform dedicated functions. Unlike general purpose computers, they are designed to execute a specific task reliably and in real time. A microwave oven is a good example where the embedded system controls timing, user input, and output devices efficiently. Now, the technologies and concepts I learned during this internship. During the internship, I learned various embedded system concepts such as embedded C programming, like basic data types, conditional constructs, operators, pointers, functions, storage classes. I also learned GPIO handling, LCD interfacing, matrix keypad scanning, and timer based operations. I also learned the importance of modular programming and state machine based design, which are essential for managing multiple operating modes in a structured manner. These concepts were later applied directly while developing the microwave oven simulation. Now, the project overview. The project implemented during the internship is a microwave oven simulation. It is a menu driven embedded application where the user interacts using a matrix keypad and all system information is displayed on a character LCD. The system displays operating modes, time, and temperature on a character LCD. It supports multiple cooking modes such as macro, grill, convection, and a quick start option similar to a real microwave oven. Now, moving forward to the project requirements. The system was based on clearly defined functional requirements. It is required to display a power on message, allow mode selection, accept time and temperature inputs, and show a real time countdown during cooking. It should also support pause, resume, and stop operations and indicate ongoing cooking process with the help of fan, which is also used for other technical purposes. Now, this is the block diagram. This block diagram illustrates the overall system architecture. The microcontroller in the middle is the center of the system. It acts as the control unit, receiving user inputs from the matrix keypad and displaying operating modes, time, and temperature on the CLCD. Based on the selected operation, it controls the fan during cooking to indicate the ongoing process. Now, the hardware requirements. The hardware components used in this project include a microcontroller, a 16 by 4 character LCD, a matrix keypad, a fan, and a power supply. The microcontroller acts as the central controller, receiving inputs from the keypad, processing the logic, and controlling the output devices. Each hardware component plays a specific role in simulating the microwave oven behavior. Now, we will discuss the software design approach. The software is designed using a modular approach where each functionality, such as display handling, input keypad, and the timer control, is implemented in separate modules. A state machine based logic is used to manage different operating states like mode selection, cooking, pause, and stop, which improves readability, maintainability, and reliability of the code. Now, the development tools I used. The project was developed using embedded C as the programming language. MPLABX IDE was used for coding and project management, along with X8 linker compiler. Debugging was mainly performed by observing the LCD output and verifying system behavior during different operating conditions. Now, the main part implementation. First, power on and mode selection. At startup, the LCD is initialized and a power on message is displayed. The system then continuously scans the matrix keypad to detect user input. Based on the key pressed, the corresponding cooking mode is selected and displayed. This provides a simple and user friendly interface for mode selection. Second, time and temperature entry. The user enters cooking time using the keypad and the selected field blinks on the LCD to indicate active input. In convection mode, the user is also required to enter the temperature. Input validation is performed to ensure correct values before starting the cooking process. Third, cooking control logic. The remaining time, oh no, once the cooking starts, a countdown timer begins and the fan is turned on. The remaining time is continuously updated on the LCD. The system allows the user to pause, resume, or stop the operation at any time using the keypad. Fourth, the convection mode. In convection mode, the system first performs a preheating operation based on the selected temperature. After preheating is completed, the system automatically transitions to the cooking phase. This behavior closely simulates the operation of a real microwave oven. Now, concluding my presentation. In conclusion, this project successfully demonstrates the implementation of a microwave oven simulation using embedded C. I successfully implemented a microwave oven simulation that meets all the specified functional requirements. This project allowed me to apply theoretical concepts in a practical and meaningful way. Now I will demonstrate my project. It will be the working including the mode selection, time entry and cooking countdown. Opening the empty lab. These are the codes. Now I will clean and build my project. As we can see, build successful. That means it has no error. Now opening the Peak SimLab simulation software. Here I will upload the hex file. It is stored in the microwave oven.x project. As you can see, the LCD is initialized and it is displaying the power on screen. Now, this is the menu screen. First, we can press the keys and select the cooking mode. First, I will be selecting the macro mode. As we can see, it first displays the power. Now, this is the set time screen. We can set the time. The seconds field are blinking, that means we can set it. I am now setting it to 22 seconds. If I press one more time, now you can see the minutes field are blinking. I can clear it by using the star key. Now I can press the hash key and it will start the cooking process. Here we also have option to pause the cooking by pressing the fifth key. We can also start the cooking, resume the cooking by fourth key. We can stop the cooking by using the sixth key. Now moving on to the grill mode. Here we can directly set the time. I have set it to 10 seconds. I will press hash to begin. After this message, it goes to the menu screen. Now I will press the third key and start the convection mode. In this, I can set the desired temperature I want, and I can press hash to start the preheating. The oven will preheat for exactly 60 seconds for the desired temperature that we selected. Now, when the oven will stop preheating, it will transition back to the timer screen. We can then set the timer and the cooking process will start. Now, the preheating is done. And I can now set the time. I can clear it using this. I can press hash and start the cooking process. I have cleared the time. We will set the time as 20 seconds and we will start the timer. Now the cooking process has started. We can pause it. We can resume it and we can stop it by pressing the key 6. Now the last mode is the start mode. This is a quick start mode. When we press the key 4, it will directly start the micro oven. It will start down counting from 30 seconds. Here we can pause it by pressing key 5. We can resume it by pressing key 4. In this mode, we can also add 30 seconds in our time. As you can see, now it has become, I pressed it 2 times. So now it has become 1 minute 12 seconds. I can also stop it by pressing 6th key. Now it has transitioned back to the menu screen. So this is how the implementation process has gone. This is the microcontroller board and we have implemented the process of a microwave oven on it. Here I have selected this PIC 16F877E microcontroller. Thank you.